Aaron Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Happy Friday to you. It is a little after 12 o'clock. I am LTTP. It's okay. A lot to look at. Cram in the last 10 minutes before we did this broadcast just to make sure I got everything in my memory banks to discuss. So good to see you guys out there on the social media landscape, our new world that we live in. What? Weather Plaza says a tornado came very close. Uh-oh, that's no good. Where do you live? You must be down there in southwest Oklahoma. Speaking of which, the Weather Service did a quick survey. They're not finished. They just want to report their early results from that tornado down in southwest Oklahoma that we covered live, and that is an EF2 so far. That was quick, easy damage that they spotted. They're now looking for EF3 or greater for the rest of this afternoon, and we'll update and report back. So that was a pretty nasty tornado. Thankfully, the cap held pretty good across the rest of the state, and even the ones out western Oklahoma. The favored region ended up being that southwestern quadrant for surface-based tornado-producing storms. There were some that tried a little bit north of that, but a little elevated and then just wasn't quite right, so that was good. Anytime you can get away with an atmosphere that can produce tornadoes and they don't, that's always a win. So we've got another one of those today and also for tomorrow. So thanks for being here. Make sure you like and share the video. Tell your friends and family about AT's Weather. Subscribe to the channel that you're on, whatever it is. If it's Facebook, if it's YouTube, if it's Twitter X, Rumble. Hit the buttons, and that way you'll get notified. We will be going live again probably this evening, if not for the tornado aspect in southeast Oklahoma, but also just for the forecast for Saturday, because Saturday, I'm over it. You over it? I'm over it. So Saturday looks like a potentially nasty day. Once again, the cap may save us all, or will it save almost all but one? You know, one of those deals. If we can get just one storm instead of multiple, it'll be a win. However, that one storm like last night will be a big tornado, and if it's over a populated area versus out in the middle of nowhere, different story, right? You take that that tornado we had yesterday in southwest Oklahoma, and you put it in a major city area, obviously and that's trouble. So thank goodness we have a lot of land in Oklahoma that's not inhabited, a lot of farmland, very, very few structures, because that's, we get too many of these things around here, right? All right, so let's take a look here what we got going on for you. First thing, look outside. We do have some sunshine. It's a pretty nice day. We have 77 degrees, and you see that little wind anemometer direction northwest. So yes, we've had a cold front roll through. Let's take a look here. You can actually spot the front on the radar. So this little line of mine, I'm going to let it shine. That little nursery rhyme. Anyway, this little guy right here, that is the cold front that is moving in this direction. So even detected well on the radar views, you can see how it moves from northwest to southeast. So that'll be the focusing mechanism for some storms later on today. You can also see that in the surface analysis, and this is where the front kind of stretches from around the Bartlesville area, just east of Stillwater, again on the southeast side of Oklahoma City and Norman, and it kind of snakes back down here around Duncan, and then back out here south of Lawton. So this front will continue to press to the south and east, temperatures into the 70s currently behind it. Also 70s and some 80s out ahead of it, but the dew points here are all into the 70s. That's sticky gross. Dew points here into the 40s, even some 30s. That's dry air. That'll make your skin crack. So big difference in the atmosphere and the air mass changes here across Oklahoma. If you look at the visible satellite picture, you can actually see the roll cloud. What's a roll cloud? You're looking at it. This guy right here. And it is a baroclinicity zone, which is basically what the front is. A lot of times you can't see a cold front, right? I mean, it's a thing that we talk about, but it's not something you go, oh yeah, there it is, I can see it. Well, there's some giveaways, and a roll cloud along that boundary is it. So that's where the baroclinicity lies. So if you want a visual look to what a front looks like, you see this right here on the satellite view. Of course, you can go outside and look out your window as well and see it that way as well. Okay, so let's move on here. For today, a severe weather risk is in effect here from right around the Muskogee area, I-40 down to Ada and about Ardmore, and then back down to Dallas-Fort Worth. Enhanced risk there in the orange. Otherwise, again, no problems out across western Oklahoma. Now, this risk for today, the enhanced that the Storm Prediction Center put out is mainly for the hail. In other words, they expect some big hail with these thunderstorms that do develop. Tornado threat is there, it's just low. So again, I could still see a tornado or two, one or two, somewhere here in southeast Oklahoma, or even northeast or north Texas, down toward Dallas, not out of the question. Now, as we head into Saturday, that is a bigger severe weather day. They already have an enhanced risk in this zone in orange. They'll probably change it to a moderate risk up here into Kansas and western parts of Missouri. And the reason why it'll be a moderate risk up there is because the cap is extremely weak to almost non-existent. So therefore, it'll be a lot easier to get widespread severe storms, which means a lot more severe weather reports. As you travel south, that cap gets stronger. Therefore, I believe at this point in time, unless something changes the model data quite drastically for tomorrow, they might just keep us in the enhanced risk. But the enhanced risk really could extend down south and west. But regardless, a slight risk still means severe storms. And guess what? You can have a severe storm over here. You can have a severe storm here. You can have a severe storm here and here. All outside the bulk of the risk area, right? It's just in that vicinity. That's where they're trying to outline the best ingredients. Doesn't mean that the storms will behave themselves in those zones. Okay, so let's take a look at the close-up view of that. For right now, baseball size hail winds up to 80, medium tornado potential. So again, there's our enhanced risk here for Oklahoma City. This is for tomorrow, for Saturday. Let's see, the tornado risk they like this little corridor here, but we're going to look at some model data to see if that agrees. I do expect some massaging in the data as usual. By the way, for Friday, for this afternoon, there's that risk from Ada to Ardmore again, down toward the Durant region for today. So baseball size hail, 80 mile per hour winds, etc. On the Tulsa side, that's down here as well. Like we said, from Okmulgee, I-40 down toward Hugo and Ardmore. Slight risk elsewhere, limited. In other words, a lower end tornado potential, but not zero, of course. And let's see here let's go Saturday. So Saturday, Tulsa keeps just around their area to the north. Right now for the enhanced area. Slight risk elsewhere. And as far as Sunday, yes, there'll be some more storms, but they'll be on Sunday in far eastern Oklahoma. So basically the eastern third of the state is where that threat lies in Arkansas. And so let's get that out of here, though, for at least Memorial Day weekend. I'd like to at least squeeze out one nice day of the holiday, right? Well, here's a look at the AI models for today. They do indicate a little bit better of a probability for tornadoes in the brown here across southeastern Oklahoma and also to North Texas and Central Texas. Otherwise, obviously a higher probability way up north. Same thing for the wind and hail. So standard stuff this time of the year. And then for Saturday, let's take a look at that. Has a bullseye right over the I-35 corridor, including Oklahoma City for tornadoes. So obviously a little different than what the Storm Prediction Center and the National Weather Service had outlined. And we'll see how everything changes for tonight's data and also tomorrow, of course. Otherwise, wind and hail, usual stuff. Okay, if we look at the analogs for today, it did favor a small percentage of a tornado event in southeast Oklahoma. And if we look at the day 2, so for Saturday, it does favor Kansas, parts of Nebraska, and western 2/3 of Oklahoma, a little sliver of northwestern Texas. If you do look at the NATOcast, which is another AI model, for today, it does favor a little higher probability of tornadoes down across the Dallas-Fort Worth area, from there southward to about Waco and out to the west a little bit, and then back up north into Paris and far southeast Oklahoma around Durant, etc. Another little secondary area there in Missouri, and also up further north from there. And then on Saturday, let's see what that one is. Now, Saturday, McKinley, remember the cap being much weaker, it's really going to favor this area here across Kansas and Missouri. Sweet spot it likes right now in the data here, but that extends well into the I-35 corridor and down to southwest Oklahoma and northwest Texas, which is why I told you we might see those risk areas drawn a little bit more down to the south and west to accommodate trends in the model data. Now for tomorrow afternoon, we do have this little disturbance that's coming through. It's kind of more of a trough axis than like a closed upper level low. There is a low here in the height field, but it's more of just this swing. And what this is these colors represent the lift that comes out ahead of it. So you see how the bulk of the lift is anchored just to our north and west. We're kind of on the southern edge of that, so a little bit more subtle for us. We have to more depend upon just brute forcing from daytime heating rather than a synoptic deal. It's a mesoscale deal at the lower levels with like the dry line position, any surface boundaries, any convergence, all kinds of stuff. But as we head to the afternoon, the dry line is expected to at least have a lot of lift along with it out across western Oklahoma to try to break the cap. We do look at the tornado parameters for today and tomorrow. For today, down here across the little sweet spot in southeastern Oklahoma. So again, those are the best ingredients for trying to produce tornadoes today. And as we head into tomorrow, let's do 36 hours. You can see the tornado parameters are favorable across a large area of, just about the whole state is an enhanced region for tornadic activity that would be significant should any storm take advantage of this environment. Now that is right about 7 o'clock. Now you remember me, I tell you if there's a storm that continues to linger between 7 and 9 o'clock, usually that can tap into a little bit better conditions because low-level jet kicks in, etc., even though the cap starts to build in. So here's a look at that. Look at these colors that you see here. This is up around 9, 10, and the chart really is supposed to stop at about, I think it's 8.5 to 9. So it's right at the top. It's pretty much anything you could ask for if you're a storm chaser or someone who wants tornadoes, because hey, the environment is conducive for just that type of an outcome. So Saturday, the potential is on the table. So we have to watch that very carefully. Here's a look at for today. Draw a line in the sand for the front. South of that is where you're going to find all your instability and your shear. So obviously you have good directional shear down here, although it's a little weak at the lower level as far as speed, which will help to limit the tornadoes. If you only have a surface wind out of the south-southeast at 5 knots, that's the surface storm really likes to have a surface wind 15, 20, to be honest with you. Now it can, as the storm gets stronger, bring up its own micro, hyper-local wind field increase, but that's just because the tornado is about to generate. But regardless, the storm likes to have a stronger low-level wind, so that'll be a negating factor down there is what I'm trying to say. All right, other models here indicate where all the instability is in that area. Some models produce a lot more storms than others. Now let's zip on into tomorrow afternoon. Same idea. We'll look at a couple of the model trends. Now it depends where the dry line is, so let me use the right deal here. So let's just assume this is our dry line in this particular model. In this model, dry line's a little bit more to the east. This model here, dry line's way out here. This model here, the dry line's way out here. And this model here, the dry line is here. I'm like, okay, well, what are you guys doing? You can't all be right. Someone's going to be wrong, or maybe all of you are going to be wrong. The point being is, wherever this dry line decides to set up, and usually, just the pro tip here, I like to go with the NAM, usually, for dry line position and moisture return. And that's the one that's way out here, the 3-kilometer NAM. However, I've got something that's conflicting with me on that position, which makes me think it's more like this. All right. Now, the problem more like this is that means you get storms that form here and here and here and here on the eastern side of the dry line down here. So pretty much anywhere in this zone. And these storms move in a northeastern fashion. And if they turn hard to the right, in other words, they're rotating very hard and produce tornadoes, then they go more in this fashion. All right. So that is what concerns me. And with the close proximity, late afternoon and evening. So this is the Rufus model, we call it. Here's the 3-kilometer NAM. Still plenty of instability and shear to work with here. There's the NAM, the bigger brother. Here is the HER, and here's the GFS. So GFS is the lamest of all. The HER, now this model is actually designed for events like tomorrow, because a lot of times it's not very trustworthy. Let's just put it that way. But tomorrow is the afternoon in which, so what happens to these modelers? They take these type of environments and they take these supercells and they train and they build the models based off of like the worst case scenario. So the model sometimes does its best when it's given that type of a parameter versus in other types. For this particular one, just for example, it fired off some storms out here. I noticed this little signal. That's some storms fired. Now it's got the dry line roughly, like I said, about here. So it's a little misplaced. And I think, So what happens is you may have a different secondary surface, like a pre-funnel trough, some type of surface convergence, where even though you're bone dry out here, you still have a secondary area of dry air that filters in here, maybe a little bit of a southwest wind, something in between. There's something in the data that's signifying that. Now, if we look at where that storm has developed, that little weak spot, what you'll notice in the forecast sounding is that the convective temperatures in the mid-90s and the surface temperature is around 91, 92. So it sounds like because of this increase, a little bit in dry air because of the extra heat, that was enough to break the cap in this region and get a storm to go and start to develop here as it moves into Oklahoma City. So we're going to look at the output on that here in a minute to see what that looks like. But that was one of the things I want to talk about. Here's a look at the NAM, by the way, for the moisture today, which signifies the front. Again, the purple dew point values into the upper 70s out here in southern and southeastern Oklahoma. So that's where your juice, your instability is. If we head into tomorrow, like we talked about, the NAM, 3-kilometer NAM, is way out here as far as the dryline is concerned. So here's where you can have your southwest winds, for example, and here's where you have your south to southeast winds. So this is a completely different look than the other. So for example, I'll go from here to the HER. All right, so on the HER, now all of a sudden our dryline is kind of snakes around. You know what? Take that back. It looks like it's more kind of like this, but you have some other type of non-established boundary here where there's something that's changed in the atmosphere. You do have a southwest wind and a south wind, so you have this other secondary regions of convergence where you haven't had the full moisture transport back. So there's something screwy going on in this zone, which is allowing some type of convergence or confluence or theta E axis, something signifying where you might get storms that form in this area where the cloud base is a little higher, temperature is a little hotter, so it kind of breaks the cap in general, and then they move into this deep moisture axis where we have dew points here into the mid 70s. So that's something I'm kind of looking at here in the data that just came in here for this morning. All right, let's take a look. By the way, this is a probability from the HER model of seeing a tornado within 120 kilometers. So 1 point, all right, so 1 point within 120 kilometers. If you'll notice, there's a high probability anchored just because of the ingredients almost over the entire state of Oklahoma. Second area is up here around Missouri and Kansas, like we mentioned up there. Look at some of these are in the 90s, 98% chance of seeing a tornado within 120 kilometers in that area. We've got a 72 to 84% chance. So obviously that's pretty significant. So the model that we're talking about here specifically is really excited about tomorrow. All right, so for today, let's take a look at the tech. And this is why I'm interested about tomorrow. So here's a look at today. It's got some storms there in southeast Oklahoma, and then through the late afternoon and evening, those move out of the state by midnight, and they move on off. If you do back this up a little bit, there's Dallas-Fort Worth, so it does have some thunderstorms around the DFW area around 5, 6, 7 o'clock before they move out. Could be tornadic, also some hail and wind, probably heavier on the hail side. Now, if we take this model in a previous run, because it has not finished today's run yet, and we take a look what it thinks for Saturday, look what happens. All right, so it's got these storms that erupt about that zone I was talking about with helicity tracks, all right, going through central Oklahoma. So these helicity tracks, again, are going to be indicative, large hail damaging winds and tornadoes. So I was like, all right, and now they keep going. So if we go to by the way, that's timing on this one was like 4, 5, 6 o'clock, just kind of give you an idea. And there's more up there into Kansas. There's 8, 9. They run into the cap and they eventually die out here by 9 o'clock or so there in eastern Oklahoma. Those ones in Kansas, Missouri keep going. Why? Because the cap is weak to non-existent up there. So they got no problem continuing well after dark. So that was the issue. I was like, why those things start so much more to the east? And if I look at its dew point map, let's see, right about that time, same look as the HER. Now, typically the WRF, the Texas Tech WRF and the HER are at odds with one another. They do not agree because they're built differently. Typically, the 3-kilometer NAM and the WRF from Tech is who agrees. And that gives me confidence in the outcome that I like what the NAM is doing, because it's usually pretty good when it tries to find out how strong the cap is, etc. But this one, like we said earlier, has that same type of a convoluted look, where it has a very good, strong dryline situation here, but out ahead of it, it has some other little goofy convergence line here as well that's much closer to central Oklahoma, where things are a little bit more high based here, which allows them to develop a lot easier with plenty of heat, because it'll get hotter in that area, a little less moisture to work with, so therefore you can get temperatures to go up into the mid 90s in that case. So that kind of weakens the cap more and allows them to develop. So normally I would have gone with the 3-kilometer NAM, which would have had the dryline way out here, but instead I'm going to go with it right here. That's pretty much what my whole point was. My argument is that I think these storms will form much closer to us late afternoon here in central Oklahoma, which means instead of us, like we normally do, watching storms out the Texas state line and tracking them east for 2 hours or 3 hours and they start to fizzle before they get here, instead they develop just west of town, and all of a sudden an hour later, as they're nice and strong and mature, tornado producers, then they go in through populated areas, and that's the problem. Okay, so let's take a look here at the 3-kilometer NAM for the afternoon. It does show you those storms there in southeast Oklahoma. All right, now for Saturday, just to show you how it thinks the cap is much stronger. Remember, it also has a dryline way out in the panhandle, so it's all a little out of sorts. 7 o'clock, all it has is a little storm down here in Wichita and then up here in Kansas, and that's it. It says the cap holds, storms go up in Kansas, etc. Those clip northeast Oklahoma overnight, and that's about all she wrote. Okay, so now if we go to the HER, and we look what it's doing. By the way, it's got some big storms this afternoon, right here, south central, technically south central, otherwise southeast Oklahoma. So right around the Ada, Atoka area, developing all the way down to Dallas. You see these little supercell type structures down here. So that's what I'm saying, heads up on Dallas Fort Worth, just in case you might have a couple of tornadoes in your backyard. So here's the season. All right, so there's 5, 6 o'clock, 7 o'clock, 8, and 9. So those are out of there by later this evening. All right, let's go on into Saturday. So on Saturday, watch so this forms. It's 6 o'clock there. It's a little late, and then boom. And then there's 8 o'clock. So 6, 7, 8, 9, 10, 11, midnight. All right, so this model keeps the storms going longer, okay? And it also forms them in our own backyard. So it's got that pseudo-convergence line somewhere in here. Now notice, just 1 or 2 storms. That still means that the model thinks the cap is going to hold in most areas, and therefore only produce a couple of supercells. Now, but unfortunately, if you notice, the focus is in central Oklahoma across a very highly populated area with a very strong, long-lived helicity tract, which would be tornadic in this case, both of these. Now, obviously, we would want that to happen. And those kind of stay tornadic. That helicity tract continues during the evening as they move east, and then tries to actually produce some new storms, probably off of some old ones or something going on up here in far northern Oklahoma for late evening through the Ponca City and Osage County area. So it's going to be interesting to see what happens on Saturday. The atmosphere is loaded. Any storm that does develop, especially supercellular in nature and can be a little more isolated, is going to have an issue where they're going to be able to easily produce tornadoes, and very significant tornadoes at that. Now, some of our other CAM models that we look at, I won't show them to you, but they're capped. They don't produce anything. So I'm telling you, the models that do produce are very few and far between, and the storms that they produce are very few and far between. So it is a low outcome as far as coverage, but a very intense outcome from the result, if that makes sense. All right, so here's a look at the RAP model. And the RAP model is also pretty good in this situation that we're looking at. It also kind of favors the HER. They're similarly built, but they usually are completely different on the outcomes. But it also favors that development here locally in central Oklahoma. And this is early as 4 o'clock to start to get going. They move up to the north and east, and then there's another one that kind of forms in the Lawton area at 7 o'clock. Now, it also has a pretty decent cap, so these things don't really linger long, and they kind of move away. Northeast Oklahoma gets some storms there for the evening, and those kind of continue because according to this model, the cap's probably weaker in that area. So, in other words, they kind of struggle here, then they get going up there for the evening hours. So it's going to be interesting to see what happens on the outcome of all this. But the bottom line is, it's a very unstable, tornado-friendly environment. The cap is going to hold for most of us, but the ones where the cap does break, we do get a couple of those supercell storms. They're not going to be fun. Rainfall amounts, Of course, you got to need these heavy storms like this model is indicating. You can quickly pick up to 2.5 inches of rainfall, and they're going to be sporadic. So here, this represents the ones for today in southeast Oklahoma. This represents those models we looked at just a minute ago, where they got a supercell here, and a supercell here, and a supercell here, and a supercell here. But outside of that, no rain, no rain, no rain. So it's one of those deals where most of us will stay dry. It's just the ones that are in the path of those storms have to deal with a lot. Temperatures. Now today, much cooler. Matter of fact, let me show you today, because this jumps in for tomorrow. And today is such a nice day, I don't want to gloss over it, temperature-wise. Let's go back here. Let's see here. Okay, so for this afternoon, we're looking at temperatures basically in the lower 80s, but this is lower 80s with a lot less humidity. So in other words, it's dry lower 80s. So a nice little breeze, it'll feel nice to you. And this is all the way up here into northwest Oklahoma. It's these 80s down here, which are going to feel gross and oppressive because of all the humidity along with it. So that's for today. Then for tomorrow, we're back into the oppressive humidity again for the afternoon. And we're going to be getting hot here in the metro, probably close to 90. Our convective temperature, depending which model you pick for storms, is in the low to mid 90s at most. So depending on which model you pick, it's going to be either a couple of degrees off or degree off, or maybe as much as 4 degrees off. We'll see. Bottom line is it's close. And then for Sunday, hot day again. And then Monday onward, temperature staying in the 80s, looks like. Overnight lows getting back up into the 60s and pretty much staying there. So there you go. All right. Well, I had a lot to tell you because it's a full weekend, and I want to make sure that you had the highlights of the concern when you're going about your business and you're not paying attention to the weather, because obviously it's that time of the year and a lot of you will be on the boats and lake houses and whatever else. Make sure you use my weather app, AT's Weather to Go. It's free on Apple and Google Play. It'll predict these tornadoes ahead of time. You can track them on the radar. And then, of course, I'll be broadcasting live should tornadoes start to develop, or looks like they will. So same old song and dance. So appreciate you tuning in this afternoon. Wish I could chat more, but had to go really long this time. I get back to work. So you guys have a great rest of your Friday. Have a great weekend, and I'll see you again tonight, this evening, and also again tomorrow. Talk soon. Take care.